Okay, today we're going to learn, we learn specific heat capacity. Specific heat capacity. As you know, specific heat capacity, low specific heat capacity, and high specific heat capacity. Low specific capacity, temperature increases, decreases quickly. Large increase or decrease in temperature, and a good heat conductor. So low specific heat capacity is a good heat conductor. Okay, and a high specific capacity temperature increases, decreases slowly. Small increase or decrease in temperature, and a poor heat conductor. So for example, low specific capacity materials are like metals. Metals are normally known as a good heat conductor. And water specific heat capacity, high specific capacity is known as a poor heat conductor. And specific heat capacity, very important. That is very important. Specific heat capacity, very important. And because some application questions are there, so specific capacity, we have a lot of applications. Okay, some application we are going to learn today. Okay, and we are going to learn questions. Okay, and as I told you, I gave this homework as questions to you. Okay, question number 17, we forget about this forever. For instance, for a while, question 17 is okay. Question 17 we can do. Okay, calculate the amount of a heat required to raise the temperature of 0.8 kg copper from 35 degrees to 60 degrees. From 35 degrees to 60 degrees. Okay, and this is a formula. Q equals to mc theta. M equals to 0.8 kg. C is about 400. Specific. C means specific heat capacity. The specific heat capacity is given in the question. Copper, specific capacity copper 400 joule per kilogram per degree Celsius. Temperature, the rise in temperature 35 to 60. So 60 minus 35. So 0.8, 400, and 60 minus 35 is about 25. It is 25. 25. Okay, 25. So it's equals to 8,000 joule. 8,000 joule or 8 kilojoule. 8 kilojoule or 8 kilojoule. Okay. Next question. Question 18. We forget about this one. For example, first question 18. I will go through it to you later. Okay. Question number 19. Okay. Question number 18. Question number 19. We'll leave it first. Then question 20. We read the question 20. Iron has a higher specific heat capacity than the copper. When heat is applied at the same rate of the two identical blocks of iron copper, which is the following will take place. Okay. The temperature rise in iron block is okay. The temperature rise in iron block is slower than the copper block. Answer D. Because the temperature rise in iron block is slower than copper block. Because iron having higher specific capacity than copper block. Okay. Because the higher specific capacity. Iron has higher specific capacity than copper block. Iron has higher specific capacity. So higher specific capacity, that's not we learned just now. Higher specific capacity, temperature rises slowly. Higher specific capacity, temperature rises slowly. So iron has a temperature rise in iron is much slower than copper. Answer D. Okay. Then question number 21. Which of the following substance has a lower specific heat capacity? Ice, water, ethanol, aluminium. They never give the number. Ice, water, ethanol, aluminum, they never give the specific capacity number. The number they never give. But they ask you the lowest specific capacity. What is the lowest specific capacity? Among the four, one is abscission, one is difference. One material is different than other materials. What is the difference? Aluminum is a metal. Aluminum is a metal. Ice, water, ethanol is not metal. So aluminum is metal. So metal normally having a low specific heat capacity. Metal normally having low specific heat capacity. Metal. Okay. So aluminum is answer. Aluminum is answer. Okay. Next question. 15,000 joule. Question 22. 15,000 joule of heat energy is raised the temperature of a 3 kilogram block of a metal from 30 degrees Celsius to 40 degrees Celsius. Find the specific heat capacity of the metal. Okay, this one. This question, 15,000 joule heat energy. That one is, this one 15,000. The Q must be 15,000 joule of heat energy. And the object mass is about 3 kg. They ask you specific capacity. Specific capacity material. The temperature rise to 30 to 40. Temperature rise to 30 to 40. Higher temperature minus lower temperature. Higher temperature minus lower temperature. So difference in temperature. Last week I told you. Theta means difference in temperature. Higher temperature minus lower temperature. So this is 15,000. 3 times C. This one 40 minus 10 is 10. So the temperature increase from 30 to 40. Temperature increase to 30 to 40. So higher temperature minus lower temperature. So this one is a 15,000 divided by 30. This one is C. So 15,000 is 500. Okay. 500. Okay. So the C is 500 joule per kilogram per degree Celsius. The specific capacity is 500 joule per kilogram per degree Celsius. 500 joule. Okay. This is objective question. The answer is the answer with the unit. If this structure question or essay question come out, then we have to write the unit. The unit is very, very important. So because the unit is given there, okay, the 500 joule per kilogram per degree Celsius. The unit is given. So the answer is 500. So the specific capacity of the material is 500 joule per kilogram per degree Celsius. Okay. The heat energy is supplied is 15,000 joule. Quantity of heat. Mass is 3 kg. C is specific capacity they want to find out. Find out the specific capacity, and the temperature rise in temperature 40 to 30 lah. So minus 40 minus 30 is 10. So 3 times 10 is 30 is 15,000, and yeah, the 30 is 500 joule per kilogram per degree Celsius. Okay. Next question 23. Question 23. Heat energy is supplied at the same rate to 250 gram water and 200 gram of ethanol. The temperature of the ethanol rises faster. The temperature of the ethanol rises faster. This is because ethanol having temperature rises faster. Temperature increases quickly. Temperature increases quickly in ethanol than water compared to water. Temperature rises in ethanol is quickly or faster than water. That means the specific heat capacity of ethanol is much smaller. Okay, this because of ethanol has smaller specific heat capacity than water. Although its specific heat capacity, smaller or lower specific heat capacity for ethanol. The answer is D. Answer D. Because ethanol having low specific heat capacity or smaller heat capacity, because of that, ethanol temperature rises ethanol faster than water. Okay. Low specific capacity, temperature rises faster. High specific capacity, temperature rises slowly. Okay, that's what we learned, and last week we learned also. Question number 24. Each of the following blocks has the same mass. Same amount of heat energy is applied to each block by the immersion heater. Which of the block will show the smallest temperature rise? Smallest temperature rise. Lead, iron, copper, aluminium. Lead having lowest specific heat capacity, under 30 joule per kilogram per degree Celsius. Aluminium is having highest 900 joule per kilogram per degree Celsius. Okay. Generally speaking, metals are having low specific heat capacity. But metal to metal, there's a difference in specific heat capacity. Higher specific capacity, lower specific capacity. But generally speaking, metal having low specific capacity. Metal having low heat capacity. So, because of that, this one is which of the blocks, the answer question is which of the block will have the smallest temperature rise, smallest increased temperature rise? That must be answer aluminium, D, because aluminium having higher specific heat capacity. Highest heat capacity means temperature rise slowly, temperature rise small rise in temperature. Low specific heat capacity means temperature rise quickly and large increase in temperature, large rises in temperature. So lead and aluminium, compared to lead and aluminium, lead having lower specific heat capacity. So lowest heat capacity lead, that means temperature rises faster, large increase for temperature for lead. But this question, the question asking you, which of the block will have the smallest rise in temperature? Smallest rise in temperature, that means aluminium, because aluminium having higher heat capacity than lead. If the question asking you which of the block will have to show the highest temperature rises, that means answer is lead. But this question asking you smallest increase in temperature, smallest rise in temperature. So the answer is aluminium. Okay. And question number 26. The specific capacity of the lead and benzene are under 30 and 1750 respectively. If the same amount of heat is applied to the same amount of each liquid, which of the following statement is true? Okay, the answer is A. Answer is A, 26. The rise in temperature of lead is larger than benzene. Because lead having lower specific heat capacity than benzene. So therefore, temperature rises in lead is larger than benzene. You must understand this one, temperature. Okay, I will tell you again. Low heat capacity. Any material having lower heat capacity, temperature rises in that material faster and large increase in temperature. What else? Higher specific heat capacity material, temperature rises slowly, and a small increase in temperature, So that means lower heat capacity material is a better heat conductor than the highest heat capacity material. Okay, so question number 26. So lead number, specific capacity lead is under 30. Specific heat capacity for benzene is 1750. So compared to lead and benzene, the lead having lower specific capacity. Lower heat capacity means temperature rises in lead is larger than the benzene. Okay. Let us do question number 25 now. Okay, question 25. Question 25. I want to teach something else to you. Okay, electric kettle is rated 800 watt. Calculate the rise in temperature of 2.5 kilogram of water if the electric kettle is switched on for the 5 minutes. Specific heat capacity water is 4200. Okay, this question is something I will need to teach you. Okay, that's why I'll hold on the question to refine. Okay, this heat energy can come from fire. The heat energy can come through the fire, or heat energy come from electrical supplies, electrical kettle, electrical heater, or electrical energy. The heat energy can be obtained, can be received from electrical appliances. Electrical appliances also can produce heat energy. Fire also can produce heat energy. The fire heat energy Q equals mc theta, straight away. But the electrical energy convert to heat energy, there's a formula. Okay, electrical energy equals to heat energy. Electrical energy equals to heat energy. Electrical energy, the formula is P times T, power multiplied time, and the heat energy formula mc theta, power multiplied time for electrical energy. Heat energy formula as usual mc theta. So the power is given, question 25, the power is 800 watt, and the time, they switch on the electrical kettle for 5 minutes, but minute must change to second. The power must be in watt and time must be in second. So 5 minutes and 60, 5 times 60, 800 times 5 times 60. The time must be in second, power must be watt, and the mass is about 2.5 kg. Specific capacity for the water is about 4200, and the theta, the rise in temperature of theta. So theta equals to 800 times 5 times 60 divided by 2.5 times 4200. So theta, I think so, 22.9, I think so, 22.9, because I don't have calculator now. 22.9, I think, based on my previous experience, 22.9 degrees Celsius. Theta is 22.9. So this is theta. 800 is the power. The time is 5 times 60 second, and 2.5 mass, and the C is 4200 heat, specific heat capacity for the water is given 4200, and the theta. So theta is 22.9. Okay, next question, question number 19. Okay, question number 19. An electrical heater is power 1.5 kilowatt, is immersed in 3.0 kg of water for 6 minutes. Given the initial temperature water is 28 degrees Celsius, find the final temperature. Okay, final temperature. Okay, this one is the same formula. Electrical energy equals heat energy. Electrical energy, power multiplied time, and heat energy mc theta. Okay, electrical energy, the 1.5 kilowatt. They want this what? 1.5 kilowatt. Question number 19. Question number 19. 1.5 kilowatt. 1.5 kilowatt you must change to what? 1500. Okay, and the time is 6 minutes. 6 minutes times 60, and the mass is 3 kg, and the specific heat capacity for water is 4200, and the theta. Okay, based on the theta, this one is theta 1500, 1.5 kilowatt change to watt 1500. 6 times 60 divided by 3 times 4200. So theta equals to, I think so, theta is 42.9. 42.9 degrees Celsius. There's the answer 42.9, but there's no answer. There's answer. 42 point. Answer is 70.9 because this is the difference in temperature or rise in temperature. Rise in temperature. The initial temperature is 28 degrees Celsius. So what is the final temperature? The final temperature. This the initial temperature from 28 degrees Celsius plus 42.9 is a difference in temperature. That is a rise in temperature or difference in temperature or increase in temperature. But to get the final temperature initial temperature 28 degrees Celsius plus 42.9. So that is what 70.9 degrees Celsius. 70.9 degree Celsius. That's answer. 70.9 degrees Celsius. Okay, now we are going to do question number 18. Question number 18. Okay, this is a different question. It's a different question. It's a very, very tough question. So you please understand this very well. Okay, you try to understand this. Okay, can you understand this one? Okay, it's electrical energy, heat energy. There's a power times time. MC theta. This one. Theta means difference in temperature. But they are asking the question final temperature. Unlike the question 25, they are asking this rise in temperature. Or that one is a specific 22.9. It's very, very straightforward. Rise in temperature. But this question 25, question number 19, they are asking final temperature. So this one theta means difference in temperature or rise in temperature. Kenaikan suhu saja. Difference in temperature. So the final temperature must be initial temperature. For initial temperature, how to rise in temperature? So the rise in temperature 42.9. So that one is final temperature 70.9. Okay, now we are going to do the question number. We are going to do question number 18. Question number 18. 0.2 kg water at 70 degrees Celsius is mixed with a 0.6 kg water at 30 degrees Celsius. Assuming no heat is lost, find the final temperature of the mixture. Okay, this question we have to do 0.2 kg. Okay, 0.2 kg. Okay, that one is I write for you. Okay. This one 70 degrees Celsius, 0.2 kg. Okay, this water and this water also. Okay, this is 0.6 kg. 0.6 kg at 30 degrees Celsius. Assuming no heat loss, find the final temperature of the mixture. So the mix. Okay, 70 degrees Celsius mix 30 degrees water. They give water. So I have another question. Maybe I might give the question to you. Okay, this one. They mix the temperature. So 70 degrees Celsius water to 30 degrees Celsius water. Both also water. So what is answer? Okay, how to do the questions? Okay. Now the temperature, the mixture of the temperature must be between 30 and 70 degrees Celsius. The mixture, let's say the mixture of temperature T must be 70 degrees Celsius. Temperature T temperature is a mixture temperature, mixture. The temperature T must be between 30 and 70. Above 30 or below 70. Okay, they mix together. Both also water. Okay, and why they never give the specific capacity water? Because both also water you will cancel each other. But I will show you now. Okay, so you mix. So the heat. Okay, let's say let's say this is A, this is B ka B. Heat B. Heat loose by heat give loose by something like this. Heat received by something like heat heat given by A. Heat given by A is equals to heat received by B. So same amount. Heat must be released actually. Heat given or release. Okay, the one. Heat released by A to B. In order to get what you call thermal equilibrium, final temperature will be same T. So heat released by A to B because higher temperature A is higher temperature, B is a lower temperature. So A release the heat, B receive the heat. So something like this. Okay. A is 70 degrees Celsius. So after releasing the heat to B, the temperature come to T. And the heat released by A received by B is 30 degrees Celsius. The heat received by B from A. Heat received by B from A, and after receiving the heat, the temperature from 30 to come to T. So the same temperature, the mixture temperature T. I repeat again. A release heat. So temperature A for 70 degrees Celsius, after releasing heat to B, higher temperature, releasing heat for lower temperature, the temperature 70 reduce, come to T. And receive heat by B from A receive heat from A, heat received by B 30 degrees Celsius. Heat received by B, the temperature rise to T. The final temperature will be T. Say temperature will be same T. So we are going to do now. So now we are going to do MC theta. This is MC theta. Okay, M 0.2 kg. The C specific capacity C is water. Water is known is 4200 . But they don't give because C and cancel because same is water, both is water. And theta temperature 70 minus T. Okay, let's say T is 50. T is 50 degrees Celsius. So the temperature of a T, they come 70 to T, 70 to T, 70 to T. T is 50. For example, T is 50. 70 minus T, the difference in temperature. 70 minus T, the final temperature T. So 70, the difference in temperature. So 70 minus T. 70 minus T. Then mass B 0.6 kg and the specific capacity 4200. Again water. So that's why they never give the specific capacity because water and water. So C and C is cancelled. Okay, temperature theta. Okay, now 30 to T. So T is 50. T to 50. So 30 become 50. 30 degrees Celsius become T. Same. Temperature same as T as A. So 30 to become 50. So difference in temperature is what? So T minus 30. It's not plus. So some people T plus 30. It's wrong. T minus 30. Because higher temperature is B is higher temperature. So B is the temperature is 50 degrees. For example, T is 50 degrees Celsius. 50 from 30 to become 50. From 30 to become 50. 70 become 50. A 70 to become 50. B from 30 to become 50. So 70 minus T. 70 minus T. So 70 minus 50. The difference temperature. But here T must be 30 to T. 30 to T. T 50 degrees Celsius. So 50 minus 30. So 50. I'll give example 50. But it's not temperature is 50. So T must be T minus 30. So must be t minus 30. T minus 30. Because 50 minus 30. So t is 50. For example, t minus 30. So this one is 0.2. This one is there is no questions and okay, but I know this answer. Answer is 40 degrees Celsius. So 0.2 times 4270 minus t and 0.6 times 4200 times t minus 30. You must get t one side and number one side. So the finally t equals to 40 degrees Celsius. Finally t must be equals to 40 degrees Celsius. Okay. So I will finish this class today. But you go through this question again. If you have any problem, you can SMS me or you can WhatsApp me. Then I will repeat the next class. Repeat this question again to you. And I will teach you the application of a specific capacity. Okay. Thank you.